go. Go ahead.
phone is turning on, so I can send the other one over as well.
All right. So let's start with, send that over. Write the equation in standard form with zeros, -3, comma, -4, with a equals -2. Okay, so we're looking for standard form. Standard form is the ax squared plus bx plus c, but they're giving you the zeros, which means you should use a slightly different form for that. Does that make sense?
Yes.
Okay, so do you remember how to write it in that factored form with these zeros?
The y equals a minus, is it x minus q or?
Yeah, P or Q. So will you do that for us? Will you write that in that kind of factored form, and then we'll talk about how to go to standard form?
The 2x plus 3 and then x plus 4.
X plus 3, X plus 4. Good. Okay, now to get into standard form, you do have to FOIL. Do you remember how to do that from last time, previous class?
Yeah.
So you first want to FOIL, and then you'll multiply everything by -2.
So x squared plus 4x plus 3x plus 12.
And then you can combine the outer and the inner, the O and the I.
X squared plus 7x plus 12. -2. So -2x squared minus 14x minus 24.
Okay, any questions on that?
No.
All right, so let me get another one here.
And I think those should be sending. It's saying not.
Okay, so here is another problem that we looked at last time. So it would, and this is not, I'm gonna have to add some words to it, but it's gonna say, given the vertex in this point, write the equation first in vertex form. So the vertex form is ax minus h squared plus k. What does that become? In this case, which is h and which is k?
The vertex h and k is 4 and 2. So
Okay, so the way this looks here, and I'll work out this one for you, is it's ax minus 4 squared plus 2. And then to find a, you use this x and y. So 3 equals a, 3 minus 4 squared plus 2. Could you solve that for a for us, please?
A equals 1.
A does equal 1, so that goes back into the previous line, and you're at y equals x minus 4 squared plus 2. Sometimes they want you to go to standard form. That could be like part B of the problem. And to do that, you have to expand this binomial. And you have to be careful here that you do it the correct way. You have to write it out as x minus 4 times x minus 4. So could you do that, expand that for us, please?
What is the next step that I do?
You have the FOIL here.
Oh, okay. So x squared minus 4x minus 4x plus 16.
So what does that reduce to? Remember, you
X
can combine the outer and the inner.
squared. Is it just minus x plus 16?
It should be the x squared minus the 8x plus the 16, but you have this plus 2 over here as well.
So my x squared minus 8x plus 18.
That's perfect. Okay, so let me have you, before we have you redo one of these, let's just have you do another expanding problem. Could you just expand like x minus 3 squared and then subtract 4 from your answer there like that? Could you just simplify that for us, please?
So x squared minus 6x plus 9.
Okay, and then combine it with the last one.
Minus 4. So x squared minus 6x plus 5.
You got it. Okay, very good. So that's your standard form. All right, let's do another problem here where I give you the vertex and a point and see if we can work through that. There it is. All right, so here we go. First, if you could put this in vertex form, and then you'll want to solve for A. Right, so I did receive some images just now. These might be good for us to go to as well. Yeah, see that this we should be doing more of these types of problems. But we'll finish up this one, then we'll go to those.
So -1 equals 1 plus 1. Oh, I have to. 2, 1, 5. The A equals 1.
All right, so you're gonna add 5 first. That gives you 4 equals A times 2 squared, which is 4. So A ends up being 1 again, which is kind of boring, but that's what they've come up with. So any questions up before we move on to what you had originally sent over for
Nope.
okay. All right. So is it okay if we do the Monday work warm up?
Yes.
Okay. There's a lot here and definitely didn't start you out with a very basic question. All right. Let me need to quickly do something. Be right back with you. All right, there we go. All right. You guys covered synthetic division last time. Do you remember that?
Yes.
All right, we did. You put the number that's the root in the box, and then you write the coefficients of the polynomial. Do you remember what you are supposed to get at the end if it works?
0.
You're supposed to get 0 here, yeah. All right, so you start by bringing the 1 down, and then you multiply the 1 times the number in the box, 5. Then 2 times 5 is 10. Add, you're always adding vertically if that's not clear. This 5 times this 5 is 25. You're adding, that's 8. 8 times 5 is 40. That's 4, 20, and you do get 0. Is that okay?
Yes.
All right. Now, the next thing here, this is a little bit awkward, but it should have been covered in class, is these roots come in conjugate pairs, which means that it's both 2i and minus 2i. They always come in pairs, plus or minus. And believe it or not, you can put a complex root in synthetic division. I'm guessing you did not see this in class, or it's kind of unclear.
Yeah, I did not.
Okay, so you bring the 1 down. That's no big deal. 1 times 2i is 2i. Now, you cannot combine these. These are not like terms. So you just write it as 2 plus 2i. 2 plus 2i. Take a look at that, see if that's okay before we proceed.
Yeah.
Is that okay?
Yes.
All right. So the next thing to do is take this 2 plus 2i and you're going to multiply it by 2i. And you probably want to do that kind of off to the side. So you're multiplying in, so it becomes 4i plus 4i squared. And you remember what I squared equals?
-1.
Yes, this becomes 4i plus 4 times -1, which becomes, and you can rewrite it here, -4 plus 4i. Is that okay?
Yes.
Right, so that's what goes here, -4 plus 4i. And then you're adding vertically, so this time you get 1 plus 4i when you add vertically. And then unfortunately you have to do the same thing. You have to take this 2i that's in the box times the 1 plus the 4i. So you're distributing in, which is 2i plus 8i squared. So that becomes 2i plus 8 times -1, which is -8 plus 2i. And there's a good thing because it does cancel out with the -8. It becomes just the 2i when you add it vertically. Is that okay?
Yes.
All right, so then you take the 2i times the 2i, which becomes 4i squared. I squared is -1, so that's -4. And wouldn't you know it, you do get 0 there at the end, which is really nice. Like it actually works out the way it's supposed to. Like I said, they come in conjugate pairs, so you actually have to then, you really want to do the -2i next. You did the 2i, now you do the -2i. And it looks really bad. It looks like, oh my gosh, like I don't really want to do this. The next one works out a lot better. Is that okay? We're just
Yes.
rewriting that line. So
Yes.
you still bring the 1 down, and then when you multiply by -2i, you get -2i. So when you add them up, you get just 2, which is good. 2 times -2i is -4i, which becomes just the 1. 1 times -2i is -2i, which gets you to 0. And notice very nicely that there's no more i's. All right, so this is x squared plus 2x plus 1. And whatever you get down to here, like whatever quadratic you get down to, typically it is quadratic, you always try to factor first before you try like quadratic formula or completing the square or any other things like that. So can you factor this for us?
And X. The x plus 1 squared.
Now, sometimes they say to write it as linear factors. So if you recall from earlier, you had the following roots: x equals 5, 2i, and -2i. These correspond to x minus 5 for 5, x minus 2i, and x plus 2i. Now, one thing you might check with your instructors, sometimes they don't like it in this form. They actually prefer it to be like this. You may want to double check and see what they want.
Okay.
right, any thoughts on that?
No.
Okay. Do you want us to do another one like that, or try this synthetic division on your own with a complex root like this 2i minus 2i? I mean, it won't be this complicated, but
Yeah.
any interest? Okay. Let me make one up that's a third degree polynomial. It's much more doable. Be right back with you. All right. Okay, so here's your polynomial x cubed minus x squared plus 25x minus 25, and 5i is a root. All right, so 5i goes in the box here. And I want you to just do your best here to figure out what goes in each of these positions.
I got to the 5i and 5i minus 1, and then I'm
You're
stuck
you're
where I have to solve it.
you're adding here, so these do not combine, so it's just -1 plus 5i. And then from here, you have to kind of go off to the side and multiply this here. So go ahead and multiply that and tell me what you come up with.
The negative 25 minus 5i.
I'm sorry, you said -25 minus 5i.
Yes.
All right, that is correct. So notice that when you add, you're always adding vertically, that it just becomes minus 5i.
So I just do negative 5i times 5i.
That's right. Yep.
So is it negative 25i?
Squared. -25i squared. What does that produce to, though?
Just 25.
So you do get 0 there at the end. And then you want to take this line here, and you really do have to do the conjugate pair with it. Like it's not enough to do just the one. So we're going to do -5i next. And you should get 0 here at the end. So see if you can work through that.
Is, does the so it goes 1 and then does it go -1?
You're multiplying the 1 by the minus 5i. So then that, yes, to answer your question, it becomes -1 there at the bottom. Good. All right. Good should see that becomes 0.
Yes.
All right. 2. All right. So we're gonna look at number 2 here, talk a little bit more about this. Um, One of the things that's really important to do is to actually look for things that you can reduce this polynomial by. You can always actually pull out a GCF. It's really x cubed plus 5x squared plus 7x plus 3. The reason you do that is it just makes the numbers get smaller when you're working with them. That's kind of like thing one to think about, is always look for a GCF. The other thing here is that you have to be careful about like factor and then root. So if the factor is x plus 3, the root is -3. If the factor were like x minus 1, the root is +1. And how you get that is you're setting it equal to 0 and you're solving for x.
Okay.
So the reason I'm bringing all that up is you have to know what to put in the box here. And what goes in the box is -3, not +3.
Okay. So
And then you actually use the coefficients of the reduced form. So that's the 1, the 5, the 7, and the 3. Yeah, probably good for you to try this one on your own. See if you can get down to 0 on this.
So I got 1, 2, 1, 0, and then -3, -6, and -3.
Take a look here. So that's -3. That looks good. -6. That looks good. -3. Good. Okay. So the idea here is that this was an x cubed. This was an x squared. This was an x to the 1 and x to the 0. And hopefully in class they covered that when you divide, it reduces it down to 1x squared plus 2x plus 1. And again, you can factor this. What does this factor into?
Um, x plus 1 and x plus 1.
Yes. Very good. Now the other factor from the beginning was x plus 3. That comes from the one that they assigned from the beginning right here. And then you also have to bring the 2 down from the beginning. Is that okay?
Yes.
All right. Let's do it's I wish we had done this one earlier, but the one on Tuesday that says to write the quadratic function, we probably should have done that, and then we can come back to the end behavior stuff. All right, so it tells you that it goes through these points. These are zeros or factors. So I would start with factored form, and then this is used to find the value of A.
So for P and Q, do you use the y-intercept?
That's used to find A. The intercepts, the x-intercepts are used to find P and Q, or they are P and Q.
So 6 equals A, 0 plus 6, 0 minus 3.
Plus 6, x minus 3, and then yeah, you're going to use that to solve for A. So go ahead and do that for me, please.
The A equals negative 1/3.
All right, so this is the first one where we actually have to put it back in and make something of it. It becomes y equals negative 1/3, x plus 6, x minus 3. Now it wants it in standard form, which means you have to FOIL first, and then we'll multiply in by the negative 1/3. So could you FOIL this for us, and then we'll multiply in by negative 1/3.
So x squared plus 3x minus 18.
Okay, very good. So when you multiply them by negative 1/3, you're going to change the sign. You're going to divide by 3, negative 1/3 x squared minus x plus 6. Any questions on that?
No.
All right, we can start talking about end behavior. Did you guys talk at all about end behavior in the classroom?
Not this week we
Okay, so the end behavior is based on two things. It's based on the degree of the polynomial, and the second thing is the leading coefficient, and more specifically, whether it's positive or negative. All right, so let's just look at one that we've already done. Can you tell me the degree of this polynomial?
have.
It-
2.
It's actually 3. It's the exponent. The leading coefficient is 2, which is positive. Let me grab some more problems here. Right, here we go. All right, so here's another one. What is the degree of this, and what is the leading coefficient?
4, and then to be -1.
-1, yeah. Good. All right, now one of the things that they will do, and you'll see that in this problem here, is that sometimes they don't put the leading coefficient in the leading coefficient position. You have to scan the whole thing and figure out where it is. So what would the degree of this one be? What about the leading coefficient?
The degree would be 4, and so leading coefficient would be 7.
Yes. Don't care, don't care.
So is it
The only
like pretty
time.
much the highest exponent is what you're looking for?
Exactly. Exactly. You got it. So before we're almost ready to do your problem here, but let me snip it in here. Can you do the same thing here? Give me the degree and the leading coefficient.
5 and 14.
Yeah. All right, very good. So let me grab end behavior reference sheet. Let's see if I can find one. So there's 4 graphs you need to know. Let me see if this is a good one or not. I don't like it. Sorry, I'm just trying to find one that's got everything in it. No, no, no. Behavior reference sheet. I just don't know why one doesn't exist for this. Okay, so there's 4 graphs. Okay, if the degree is even, you can think of like an x squared, x to the 4th, and so on. There's 2 possibilities. Either starts high and ends high, or starts low and ends low. And for the first one, this is when the leading coefficient is positive. This is when the leading coefficient is negative. So there's 4 graphs you have to know. And then furthermore, you have to know the end behavior here. And so it's summarized like this. I think it's nice to have the graphs, but this is how it's summarized here. And then the same thing is for odd degrees. There's 2 other graphs for odds. So I'm just putting these in the notes so you have them. If the degree is odd, like an x or an x cubed or an x to the fifth, it either starts low and ends high or starts high and ends low. You actually do not care what's going on in between. And then you've got two situations again where the leading coefficient is positive versus negative. And then there are, again, end behavior things to remember. But it all comes from the degree and the leading coefficient, which means that you have to memorize these four graphs. And then you can do all the problems. You should see this in class if you haven't
Yeah,
already.
I have.
Oh, excellent. Excellent. So we we are basically out of time, but you'll be doing a lot of this in the next few days, so it'll become more clear if it's not already. All right, let's go ahead and stop there.